Hi, my name is Nicholas, and for my 491 final project, I decided to create a pattern sequencer with special capabilities. This sequencer layout is very typical of any drum pattern beat maker beat machine. It essentially has two rows with two different instruments, in this case kick, and snare. Now, it wouldn't actually be that much distinguishable from other pattern sequencers if it didn't have these four, what I call status slots. They change the way in which a beat is repeated or played in what we typically call stutter edit. For example, if I activate status slot number 1 and I place a beat on the table, so this is what the system looks like as a whole. We have the pattern sequencer itself sitting on top of a TV screen that's flipped upright. And the rest of the electronic components are sitting right there on that table. And those electronic components are connected via USB to the laptop over in the desk. And the sound eventually comes out of the speakers that you can also see in the desk. Let's take a closer look. So this is the TV screen on which the system sits. I mean that the system sits on it because it's actually a plexiglass sheet with all the screws that you see right there glued onto it. I did this so that I wouldn't have to glue the screws onto the TV screen itself. Now, if we take a closer look, you can see what each one of these slots is made of. It has a ground wire, a ground black wire over here, and a ribbon wire attached to the other solder tab. Now, the ground wire goes through all the rows of all of these identical slots so that they all get the same ground current. And the ribbon cables are to complete the circuit of each individual slot. As you can see, each slot has its own dedicated cable. And here's the gap that represents an open circuit, an off message in this system right here. This is the gap that we're supposed to close to create an on message, a switch message. And when we place a metal ball in it, you can see how it makes both of them come into contact. That's the reason why when I have, I could also have tinfoil on my fingertips and just press down here and close the gap as well. Now, all of this ribbon cable is actually attached to some D-sub connectors that are eventually plugged into two multiplexer chips. Now, what these multiplexer chips are basically they have a controlled output. It's sort of like a gating function. It has 16 dedicated inputs through which it can pass signal onto its final output, which is this corner right here. Now those outputs coming from the chips, so the inputs come in from the switches, and the status of each individual switch comes out this cable into this analog input in this Arduino board. Now an Arduino board is a very versatile circuit board with artists and designers in mind to make it easier to program interactive media for the arts. The Arduino board is connected to the chips to let it decide which of its inputs it's going to heed, it's going to take care of on its output, and to register the status of each one of the slots. Now, after it has processed all of that, it is connected via USB to the computer itself. So once we get to the computer has a program which is able to provide feedback to the television set through its DVI port. And the information sent to it is to refer to which slots are activated or not, so that the TV can display correspondingly as such. And that's basically the rundown of signal flow in this hardware.